In an examination, 36 boys offered French, 32 offered German, and 31 offered Spanish. 9 offered French and German, 12 offered German and Spanish, and 11 offered French and Spanish. There were 4 boys who offered all the 3 languages, and 9 boys offered none of the 3 languages. Let F, G, and S represent a set of boys who offered French, German, and Spanish respectively. With that information, we are asked to represent it on a Venn diagram and find how many boys are there altogether. Secondly, how many boys offered at least one of the languages? How many boys offered at most 2 of the languages, exactly 1 language, and exactly 2 languages? Also, we are asked to find F prime intersection G prime intersection S prime and interpret it. The D part of the question says, find the probability of boys who offered French or German but not Spanish. Find the probability of boys who offered French and German but not Spanish. Then lastly, what percentage of the boys offered French only, and what percentage of the boys offered German only? This is a complex question from set theory that demands the use of Venn diagram. So let's get started. With this as our Venn diagram, let's label this because we are told let F represent French, let G represent German, and S represent Spanish. From the question, we are told that 4 boys offered all the 3 languages. So the point of intersection between the 3 of the languages or the subsets here is this point. So we'll write 4 here. Right? And then before we continue, let's bring out the data again. The number of French is equal to 36. We're told from the question. Also, the number of those that offer German, we are told 32. Also, the number of boys that offered Spanish, we have 31. And 9 boys offered French and German. So F intersection G is equal to 9. Also, we have the number of boys that offered German and Spanish equal to 12. While the number of those that offered French and Spanish, we have 11. From the question also, we have the number of boys that offered all the 3 languages, that is F intersection G intersection S is equal to 4. So from this, we were also told that the number of boys that offered none of the 3 languages are 9. So we have F prime intersecting G prime intersecting S prime is equal to 9. With this, the next thing for us to do is to populate this Venn diagram. When you look at this place, this is the intersection between French and German but not Spanish. This place here, that is French and German only. But we are told that French and German here is equal to 9. So we have to remove this 4 because if you look at the point of intersection between French and German here, 4 is already inside. So if we write 9 here, it will be a big error. So we have to subtract this 4 from 9 so that we'll know those that offer French and German only, but not Spanish. For us to do that, we are going to have n, that is the cardinal number of F intersection G intersection S prime. That is the intersection between French and German but not Spanish. That will be equal to 9 minus 4, and that's equal to 5. So 5 is what we will now write here. Similarly, for us to know those that offered French and Spanish but not German, we are going to use n, that is a cardinal number of those that offer French and Spanish but not German. That is F intersection G prime intersection S. So we have French and Spanish up here giving us 11, but we are looking at French and Spanish but not German. So we have to also subtract this 4 from that 11. So we have here 11 minus 4, and that gives us 7. So 7 is what we'll write here under F intersection S, but not G. Lastly, for this intersection between two languages, we have the intersection between German and Spanish here. When you look at this data also, German and Spanish, we have 12. Again, 4 of that number is already here amongst those that offer the 3 languages. So we have to subtract this 4 from 12. So come down here also and have the cardinal number of those that have F prime intersecting G intersecting S. That is the intersection between G and S and not F. That is why we are putting prime here. Anyone you are seeing prime is the one that is not considered, that is not part of that particular set per time. So for German and Spanish, we have 12 here. So we are going to subtract 4 from 12, and we will have 8. So 8 is the number that offered German and Spanish. Also, in populating this Venn diagram, the next thing we need to do is to find out how many offered French only, how many offered German only, how many offered Spanish only. And to do that, we again need to come and use this data. We are told that 32 offered German, but when you look at the oval shape, the subset for German, we already have some numbers here, number of boys already here. So we want to subtract all of this from this 32 to know those that in that particular class or examination, they offered only German. Thereafter, we'll proceed to subtract 5, 4, and 7 from that of French to get the number of those that offer French only and the likes of it. So let's continue. For us to get French only, you have French only. French only is going to be the cardinal number of, you're going to have F intersection G prime intersection S prime. And that's equal to, from this data, the total number of students in French, we have 36. So we are going to subtract this data, 5, 4, and 7 from 36 to know French only. So we have 36 minus 5 plus 4 plus 7. And that's equal to 36 minus 5 plus 4, we have 9. 9 plus 7, we have 16. So 36 minus 16, we have 20. So 20 students offered French only. So we come back to our table here or Venn diagram and write 20 for French only. The same way for German only, we are going to subtract 5, 4, and 8 from this number 32 to know German only. So for German only, we have the cardinal number of F prime intersecting G intersecting S prime. And that's equal to 32 minus, we have 5 plus 4 plus 8. And this equal to 32 minus 5 plus 4 is 9. 9 plus 8, we have 17. And 32 minus 17, we have 15. So 15 boys offered German only. So we'll come back to this German and write 15. Lastly on that, to have for Spanish only. For Spanish, we are told that 31 students offered that language. But already we have some data here under the oval shape or inside the oval shape for Spanish. So we have to subtract this number from 31 to know Spanish only. So we come back to this point and have Spanish only. Spanish only will be the cardinal number of F prime intersection G prime intersection S, and that will be equal to 31 minus, for Spanish we are going to have 7 plus 4 plus 8. That's equal to 31 minus 7 plus 4, we have 11. 11 plus 8, we have 19. So we have 31 minus 19. And 31 minus 19, that's equal to 12. So 12 is the number of boys that offered Spanish only. Lastly, for us to populate this Venn diagram, we are told that 9 boys offer none of the 3 subjects or 3 languages. Because of that, they are not part of those in French, they are not part of those in German, they are not part of those in Spanish. But since they are part of that examination, since they are part of that universal set, we'll put them here outside. By this, we are done populating the Venn diagram. Represent the information on a Venn diagram and find how many boys are there altogether. That was the question we were asked. We have succeeded in representing the information on a Venn diagram. What is left for us in the A part of that question is to find how many boys are there altogether. To find how many boys are there altogether is to sum all the data you have here in this Venn diagram. That will give us our universal set. So our universal set is going to be equal to the number of those that offered the 3 subjects, equal to 4. The number of those that offered 2 languages only. We have 5 here for French and German, 8 here for German and Spanish, and 7 here for French and Spanish. So we are going to add 5, 7, and 8. So we have plus 5 plus 7 plus 8. Also, we'll need to add those that offered one subject only. That is French only, German only, and Spanish only. That is 20, 15, and 12. 20 plus 15 plus 12. Then lastly, we'll add the number of students that offered none of the 3 languages. That is 9 of them. So let's sum this together and see. We have 4 plus 5, we have 9. 9 plus 7 is 16. 16 plus 8, we have 24. 24 plus 20, we have 44. 44 plus 15, that's 59. 59 plus 12, that's 71. 71 plus 9, that's 80. So we have 80. Therefore, there were 80 boys all together. And by this, we are done with question A. The second part of the question says, how many boys offered at least one of the languages? At least one of the languages. If asked to find how many boys offered at least one of the languages, what we are asked to get here is the number of those that offered one language plus the number of boys that offered 2 languages plus the number of those that offered 3 languages. So we are going to add 4, 5, 8, 7, 12, 15, and 20 to get the number of those that offered at least one of the languages. BI, we have at least one of the languages. Okay, for one of the languages, we are going to add the number of those that offer German only, that is 15, plus the number of those that offered French only, we have 20. The number of those that offered Spanish only, we have 12. The number of those that offered French and German, we have 5. The number of those that offer French and Spanish, we have 7. While the number of those that offered German and Spanish, we have 8. And the number of those that offer the 3 languages, we have 4. Look at how we follow this. First of all, from those that offer one language only, this is for German, French, and Spanish. Then we move to those that offer 2 languages only. This is for French and German, French and Spanish, German and Spanish, and those that offer the 3 languages, that is French, German, and Spanish. So the summation of this gives us the total number of boys that offered at least one of the languages. 15 plus 20, we have 35. 35 plus 12, that is 47. 47 plus 5, we have 52. 52 plus 7, we have 59. 59 plus 8, that is 67. And 67 plus 4, that is 71. So we have 71 boys that offered at least one of the languages. The second question says, under this, the number of boys that offered at most 2 of the languages. So let's see those that offered at most 2 of the languages. When you are asked to find the number of students that offered at most, it means that is the maximum. So we are moving the number of students that offer 2 subjects or 2 languages downward. In this case, we have 5 here for French and German, 7 here for French and Spanish, 8 here for German and Spanish, and then we add the single ones. That is French only, German only, and Spanish only. At most, two of the languages. At most, two of the languages, we are going to add the number of those that offer French and German, which is 5. French and Spanish, 7. German and Spanish, we have 8. French only, we have 20. German only, we have 15. Spanish only, we have 12. The summation of this gives us the number of students that offered at most two of the languages. 5 plus 7, we have 12. 12 plus 8, 20. 20 plus 20, we have 40. 40 plus 15, we have 55. 55 plus 12, we have 67. So 67 boys offered at most two of the languages. The next one, we are asked to find how many boys offered exactly one language. Finding the number of boys that offered exactly one language, we are going to sum French only, German only, and Spanish only. That is 12 plus 15 plus 20. Exactly one language. For exactly one language, you have 20 for French, plus 15 for German, plus 12 for Spanish. And that's equal to 20 plus 15, we have 35. 35 plus 12, we have 47. So 47 boys offered exactly one language. The last one under the B part of this question, we are to find how many boys offered exactly two languages. Exactly two languages. For exactly two languages, we are going to consider the point of intersection between French and German, French and Spanish, and German and Spanish. And that's 5 plus 7 plus 8. So exactly two languages, we have exactly two languages. We have 5 for French and German. We have 7 for French and Spanish, and we have 8 for German and Spanish. 5 plus 7 is 12. 12 plus 8, we have 20. So 20 boys offered exactly two languages. The next question here is that we should find F prime intersecting G prime intersecting S prime and interpret it. That's the C part of the question. F prime intersecting G prime intersecting S prime. Remember, while we were extracting the data in the equation given to us, we have something like this: F prime intersecting G prime intersecting S prime. Here is it. We have 9. And what does it mean? F prime intersecting G prime intersecting S prime can also be written as F union G union S prime. That is F union G union S prime. And the value is equal to 9. What does this mean? You are looking at the relationship between the number of those boys that are in that examination but do not offer French, and do not offer German, and do not offer Spanish. Also, when you find the union between the three of them, and then you check in comparison with the universal set, how many do not offer any of the three subjects, you are going to have 9. So the interpretation of this is that 9 boys offered none of the three subjects, none of the three subjects or languages as it was stated in the question, none of the 3 languages in that examination. Remember, we calculated and found that there were altogether 80 boys in that examination. However, 9 boys offered none of those 3 languages. So that is all about the C part of this question. Next, we have the D part of this, saying that we should find the probability of boys who offered French or German but not Spanish, and then French and German but not Spanish. Now, this is not the same question. When you hear about or, we are looking at the union of sets. Whereas when talking about and, we are talking about the intersection between those 2 subsets. So we are going to look at the union between French and German, excluding Spanish. In comparison with the universal set, what is the probability? Thereafter, we'll move to the intersection of French and German but not Spanish, and look at it in relation with the universal set, its probability as well. French or German includes the union between French and German. And union of sets includes all the data in a particular subset and that of the other. But since we are told French or German but not Spanish, even though French and German, they overlap here and we are free to take this data, because of that second part of it and not Spanish, we are going to trace this oval shape for Spanish and exclude all the data here. So the union of French and German but not Spanish includes 20, 5, and 15, excluding this data that was shared with Spanish. Question D, I, we have the probability of French or German but not Spanish. So French or German but not Spanish, we have P, that's the probability of F union G union S prime. And this is equal to 20 plus 5 plus 15 divided by 80. 20 plus 5 is 25. 25 plus 15 we have 40. So here is 40 over 80. Reducing this fraction to its simplest form, we have 1 over 2. So the probability of French or German but not Spanish is 1 over 2. Next, we have the probability of probability of French and German but not Spanish. This time around, looking at the word and, we're going to use intersection of set. So the probability of French and German but not Spanish is equal to, when we come to this universal set, the point of intersection between French and German is this part. That is this part where you see 5 and 4. That is the point of intersection between French and German. But we are told that we should consider only French and German, but not Spanish. So we are going to exclude this 4, even though 4 was also shared by French and
German.
Spanish. But since we don't want to have anything to do with Spanish in this particular question, we are going to use only 5. That is where we have French and German, but not Spanish. Looking at the data we extracted earlier, that is what we have here. French and German, but not Spanish. We have 9 minus 4, giving us 5. So French and German, but not Spanish, is equal to 5. Divide by the total number of boys in that examination, which is 80. Reducing this fraction to its simplest form, 1/16 is equivalent of 5/80. 5 here is 1 time. 5 can enter 80 16 times. So the probability of boys who offered French and German but not Spanish is equal to 1/16. Lastly, on this question, we are going to find the percentage of boys who offered French only and the percentage of boys who offered German only. We have percentage of French only. From this data, the number of students who offered, or the number of boys who offered French only, we have 20 here. So the percentage of boys who offered French only will be equal to 20/80. We multiply this by 100. And 20 multiplied by 100, we are going to have 2,000 divided by 80. 2,000 divided by 80, we have 25. So the percentage of boys who offered French only is 25%. Lastly, we are going to calculate for the percentage of German only. Percentage of German only. Also, looking at the data in this Venn diagram, 15 boys offered only German. So in finding the percentage of boys who offer German only, we will have percentage of German only will be equal to 15 all over 80 multiplied by 100. 15 multiplied by 100, we have 1,500. Divide by 80. 1,500 divided by 80, we are having 18.75%. So this is the percentage of boys who offered German only in that examination. And by this, we are done solving this question.